In this question, we've been told that a particle is projected vertically upwards from a balcony which is 2.48 meters above level horizontal ground. So straight away, we should be thinking about a diagram we could draw to show this situation, including the flight path of the particle. The question goes on to tell us that the particle is moving freely under gravity and takes 2.45 seconds to reach the highest point in its path, before it goes on to strike the ground with a speed of v meters per second. We've been asked to calculate the value of v. As I said, let's start with the diagram. So here's my platform, and I'll mark that as 2.48 meters. Here's the ball, and it's going upwards first. It is being projected vertically upwards, so I'll choose up as my positive direction. And here's the flight path. It goes up, at some point it reaches its peak, and then it comes back down to the ground. So I'm going to start by modeling the journey from the point of projection until it reaches its highest point. So this part of the journey. My SUVAT variables, I don't know the displacement, I don't know the initial velocity, I do know the final velocity there is going to be 0. Acceleration is negative 9.8, and it takes 2.5 seconds to get there. So into a SUVAT formula, we need one that uses v, a, and t, and I'm actually just trying to find the initial velocity. So v, u, a, and t go into this formula. Substitute, rearrange, and solve for u. And we get 24.0 meters per second. Now we know the initial velocity, we can think about the entire journey. S, U, V, A, and T. The displacement is going to be negative 2.48. It's landing below the projection point. Thinking about the positive direction, this is backwards according to our positive direction. So a negative displacement, 2.48. Initial velocity, we just found that. I'm going to put 24.01, the full version of the answer. Acceleration is negative 9.8. And the time. We're looking for this final velocity, the velocity which it hits the ground with. So, v squared equals u squared plus 2as. Let's go ahead and substitute, simplify, and solve. So, v squared equals 625.088, and the square root of that takes us just down to 25.0 meters per second. The velocity this particle hits the ground with is 25 meters per second.